Hello everyone, I wanted to do a brief video on what your maximum and your minimum look like if we have multiple variables. Say we have an x, a y, and a z, and in this particular case you can see x, y, z. Okay, what it does is it gives you a set of points that are now 3D or three-dimensional. So your relative max looks like the top or the bottom part of a bowl that's turned over, right? So if the bowl is looking like that, then there's your relative maximum, okay? And you like to find that using the skills and tools that I'll show you in some of the upcoming videos. What does the relative minimum look like? Well, it looks like a bowl that is right side up, and it is the bottom part of that. So hopefully you can see your relative minimum is about there. It is the lowest point in its region. Okay, so again, these are 3D points that you're taking into consideration. Okay, so I also want to show you what a lot of students like to call a three-dimensional inflection point. This isn't a three-dimensional inflection point, but I understand how students can perceive it as such because it is the third option. You don't have a max, you don't have a minimum. Instead, you have what's called a saddle point. Okay, and you can kind of see why it's called that. Your saddle point is right there, right? So it looks like you're right in the middle of a saddle. And the reason that this can't be a maximum, because if you were sitting at this point, notice max has to be the highest in this region. But look, behind you, all these points are higher than that. So this isn't a max. And all these points in here, right in front of you, if you were sitting on this, would be higher than this point. Okay, so you can't call this a minimum either, because if you were sitting right at this point, look where your legs would fall, down here, right? So all of the points where your legs would fall would be lower than this, so this couldn't possibly be a lower minimum, but instead it's called a saddle point. Okay, so please keep those things in mind. There was one more thing that I want to show you, and that is the notation that I'm using for the partial derivatives. Okay, so you guys can certainly look this up in your book, but this is what I'm attempting to write with my fancy d or my delta. This is the change in my overall function relative to my change in my x. Okay, here's additional examples. Here's your partial with respect to x of your function, partial with respect to y of your function, partial with respect to x twice, and partial with respect to y twice.